Fall 2021 AMC 12B solutions. So let's get started with the first problem. So for this problem, if you want to do pure calculation, it will not be too slow. However, it will still waste some of the time because you see that all of the numbers that we're trying to add are essentially the permutation of 1, 2, 3, and 4, right? So, and we also see that every one of them has one time occupying each of the digit. So basically, we're just going to have 1 plus 2 plus 3 plus 4, right? And then we have, you see 10 cubed plus 10 square plus 10 plus 1, giving us 10 times 1000 plus 100 plus 10 plus 1, which gives us 11,110 as our answer. Let's proceed with the second problem. So second problem asks us to find the shaded area below. So this one is a pretty simple problem. There are multiple ways to do it, but the pretty natural way was just to cut it into two identical triangles. So for the left triangle here and the right triangle here, we see that the height is going to be from 1 to 3, which gives us 2, and the base is from 5 to 2, which gives us 3. So each of the triangle, we call this S1, call this S2, then S1, which is the area, is going to be equal to 3 times 2 over 2. But then we have two identical ones, so we're going to multiply by 2. And these two simply cancel out, give us 6 as our answer. See to problem 3. At noon on a certain day, Minneapolis is n degrees warmer than St. Louis. At 4 o'clock, the temperature in Minneapolis has fallen by 5 degrees, while the temperature in St. Louis has risen by 3 degrees. At which time the temperature in the two cities differ by 2 degrees, what is the product of all possible values of n? So this problem is pretty straightforward because we can just try to consider what are the cases that will result in what we desired. So the first case is obviously when you have this is the lowest temperature, the blue dot, and red dot is the highest temperature. So if we go down by 3, and then we go up by 5, and then we differ by 2. So this is case 1. However, we also have case 2, since we have a trap answer right here with 10, and we definitely do not want to fall into a trap answer. So the second case is when you have black dot and red dot and the blue dot here, and then red you go down by 3, and then then blue you go up by 5. However, you have the two dots which you overlap, and this dot is going to give us 2. So this length in this case, we're going to have 5 plus 3 minus 2 is equal to 6. And on the left side, we have 5 plus 3 plus 2 is equal to 10. And we're asking to find the product of all values of n. So the answer is going to be 10 times 6 is giving us 60 as our answer choice C. Equals to 8 to the 2022's power, and which of the following is equal to n over 4. So a really clever way would be to express everything in terms of 2, right? So writing to the power of 2, then we know that 8 to the 2022 is basically equal to 2 raised to the third power, and then raised to the 2020's power. And then we can multiply those together, we get 2 to 2026, and 4 is equal to 2 squared, so the answer is 2 to the 2006 minus 2, giving us 2 to the 64 power. And then we see that if we convert all of these into base 2's exponent, then you're going to see that E is going to be our answer. Fraction it will be not necessarily in the simplest form, special if a and b are positive integers whose sum is 15. How many distinct integers can be written? The sum of the two not necessarily distinct special fractions. So first we're going to actually make this set. So the set is going to be equal to 14 over 1, 13 over 2, 12 over 3. Well, actually we can just replace this to be 4. 11 over 4, 2, 3 over 2, 8 over 7, 7 over 8, 2 over 3, and then 1/2, and then 4 over 11, 1/4, and then we have 2 over 13, and 1 over 14. So these are all of the possible ones. So first we're going to do it by casework. So int. So this is going to be the first case. So this case will be 14, 4, 2. So this will produce what? So this will produce 18 by adding them up, 6, 16, and then we can have double of them. So we have 28, 8, and 4. So we're going to also account for a second case. So case 2, they have the denominator is equal to 2. So this will give us 13 over 2, 13 over 2, and 3 over 2, and 1 over 2. So this will give us 8, 2, and 7, and then double these 3, 1. So these are all possible for now. And then we have to also account for case 3, which is d equals to 4. So d equal to 4, when you're going to have 11 over 4, then you're also going to have 1 over 4. So this will give us 3 as the only one. So now we cannot just simply add all of them because there's clearly overlaps, which we can see that 8 is an overlap, and 3 is also an overlap. So the answer is going to be equal to 2 times 6 plus 1, but then we also don't want to minus the overlap, which is equal to 11, giving us answer choice C.